We're now on 1.4, solving equations. Once again, we're reviewing Algebra 1 concepts, so we'll be briefly discussing these properties of equality, and some of which I will provide examples for. If you need further clarification, we'll meet up either as a whole class and discuss, or in a small group setting. So as we move through this, remember that at any point, if you need to schedule a time to go over anything in particular, let me know. But at this point, this is all review from pre-algebra, algebra, and geometry. The reflexive property we saw a lot in geometry. So a number is equal to itself. So for example, 5 must be equal to itself. The symmetric property, think of symmetry. In an if-then statement, if A equals B, then our conclusion is that if we flipped B and A, flipped symmetry, then B must be equal to A. So for example, if you stick some numbers in there, if 1/2 equals 0.5, then switching the equation, 0.5 equals 1/2 would still result in an equation that is the same as the original. Transitive property we also saw a lot of in geometry. If A equals B and B equals C, then our conclusion is, since A and C are both equal to B, that they must be equal to each other. Substitution property we use frequently, and we see that again in systems of equations. But if we know that two values are congruent to each other or equal to each other, if A equals B, then A can be replaced with B and vice versa. Addition property of equality allows us to add two values that are the same to both sides and still yield an equation that is equivalent to the initial one. So if I have A equals B, then I can add the same quantity on both sides and we would still have an equation that's true. Same thing for subtraction, or you can even think of it as adding a negative on both sides. But if I have A equals B, I can subtract C on both sides. And then multiplication and division, if A equals B, then I can multiply the same quantity on both sides and still have an equation that's true. And finally, with division, if you're initially given A equals B, then your conclusion is that if you divide by number C on both sides, that equation is also true. Now, in the very beginning of, I would say in the middle of pre-algebra, beginning of algebra, you get two equations where you're isolating X and two unique situations results. So for example, when you're solving equations, you're combining like terms. So on the left-hand side, you have 11 minus 7 is 4 plus 3x equals, on the right, we have 6x and minus 3x. So that results in 6x minus 3x is 3x plus 5. Something funny happens though, as I'm trying to isolate my x, I do the additive inverse of positive 3x is negative 3x on both sides, and the variables go away. The resulting equation is 4 equals 5 with no variables. And then we ask ourselves, when is this ever true? When is 4 ever equal to 5? Never. So if that's the case, my actual answer is no solution. There was no values of x such that it would prove that initial equation true. As opposed to the second unique situation where you get identity as an answer. So in this case, you have that you're combining like terms. 6x minus 2x is 4x on the left. And then 4 and 1 you can combine to be 5. And if you look, 4x plus 5 equals 5 plus 4x. Well, that is the symmetric property. That's always true. So if you have two things on both sides that are equivalent, where the x's are still there, or if you choose to go further and subtract 4x on both sides and get 5 equals 5, when is that ever true? Well, that's always true. So if that's the case, then this is an example of identity, and your solution is what we say is all real numbers or identity. in science, one of the most important things that they wanted algebra teachers to go back on is to make sure that you understand how to solve a literal equation. So given an equation that might not have any numbers in it and a few variables, are we able to isolate the variable that is required for the problem? So these are two familiar equations that you'll notice. For the first one, you have A equals B times H. Area equals base times height is the area of a parallelogram. And they want us to solve for H in terms of A and B. So what that means is when they want you to solve for H, that means they want you to isolate H using the properties above. So since B is separated by multiplication from H, to undo B so that we can isolate H, we would divide on both sides by B. So in isolating H, our conclusion is that solving this literal equation, H is equal to A over B, the area divided by the base. So it's really just isolating a particular variable so that we can eventually solve for that variable. So the equation area equals 1/2 height times quantity base 1 plus base 2 you would recognize as the area of a trapezoid. And they want us to solve for base 1. So the equation right now lends itself to situations where we want to solve for the area. However, if we wanted to solve for B1, how do we go ahead and isolate that? You'll see that B1 is inside the equation, and we want to isolate B1. So what we're going to do is have to undo those parentheses. So how do we do that? There's one of two ways. So the first way is, let's go ahead and get rid of the parentheses by distributive property. So if we do that, we distribute 1/2 H to B1 and to B2. And that will allow us to get a little bit closer to isolating what we want, which is B1. So now what we'll do next is, so we want to isolate this guy. So what we'll undo, there's two terms right now. We'll undo the plus. We have A on this side. So A minus 1/2 H B2. Then we'll move that B2 term to the other side and get B1 closer to being by itself. And then lastly, you have 1/2 times H times B1. So to undo all that, we can divide over 1/2 H to the other side, or we can do things like, well, to get rid of the 1/2, I can times by 2 the multiplicative inverse on both sides. So I can times 2 on this side, make sure that it's a quantity on that side. And then finally, to get rid of H, we would divide the whole equation through by H. So B1 is equivalent to 2 times the parenthesis times the quantity A minus 1/2 HB sub 2 divided by H. Okay, now the question is, was there an easier way to have done this? Well, that really depends on the person. But if we had began the equation with, and you know what, I'm going to work a little bit down here. Area equals 1/2 H B1 plus B2. So what else could we have done here? Instead of distributive property, what else could we have done? Okay, so if you thought maybe we could have just gotten rid of the 1/2 in H through timesing by 2 on both sides first to get 2A equals H B1 plus B2. How do we undo the H, which is being multiplied? Well, we can divide both sides by H. Okay, here we go. We're getting closer. And now we have 2A, well, let me switch colors. We have 2A over H is equal to, the H is on the right-hand side, were divided out. So now you just have B1 plus B2, which is nice. And lastly, we want to isolate B1, so we're going to subtract B2 to the other side. This expression is much more simple to work with than the equation that you have over on the left. But both are acceptable. If we were To simplify a little bit further, we would see that they are both equivalent to each other. So whether we have our answer written like this or like this, we've isolated B1.